Dear cadets, so yesterday I taught you the mechanism of formation of micelle. So once again I am telling you, micelle is nothing but a aggregate ions of substance. Substance may be soap also, and they orient themselves in a such a way so that their hydrophobic part should be interior of the cluster and hydrophilic part should be at the surface of cluster. So in another way also we can define micelles are nothing but a clusters of ions in which they orient themselves in a such a way so that the hydrophobic part should be in the interior of the cluster and hydrophilic part should be at the surface of cluster. So in this way, in the simple language we can say micelle is nothing but a cluster of ions, aggregate colloids, okay, and soap is one of the substance which form the micelle. Detergent is also the substance which form the micelle. Now today I am going to teach you cleansing action of soap. So soap can clean the dirt, fat, oil particle by micelle formation and emulsion formation. Okay, both are playing important role in the cleansing action of soap. The first one is micelle formation and second one is emulsion formation. Let us see. Suppose you have taken soap. So what is the soap? This one. What is chemically soap is sodium salt of higher fatty acid. Study only the entire structure: hydrophobic, hydrophilic, polar, non-polar, head, tail, hydrocarbon, ionic, non-ionic, all words I have explained. Okay, and yesterday's video was near about 38 minutes. Okay, why I took so much time? So that within one stretch only you understand all those things. And it is not so simple because you have to understand. That is why if you don't want to understand, everything is simple. If you want to understand, then you have to apply your brain. So we remember this one, that hard work never goes in vain, and there is no substitute for hard work. Keep on working. At least you are in the touch with the syllabus. And you know this COVID-19 pandemic, when it will end, nobody knows. Okay, so rather than wasting the time, it is better to concentrate on the syllabus which is being taught. Okay, slowly. But it means, meaning of this one is you should not be distracted from the syllabus. You should be on path. Of course, some problem is there. I know that getting all those things through online mode, it is difficult because it is one-way process. It is not a two-way process. In the class you are asking so many doubts. Now almost it is one-way process, but there are several platforms by which you can raise your doubt, you can air your doubts. The WhatsApp group is also there. Now Google Classroom is also there. There are so many things. Little bit just exercise the effort, your problem will be sorted out. That in one group, if children are asking, I may not answer that point of time, but definitely 101% I will answer. So please keep working. Okay, so just see. This is soap. What is this one? Soap. Okay. When soap, it is better to take here. Suppose this is one dirt. This is one piece of cloth. What is this one? One piece of cloth. And here what is there? Dirt particles are there. Generally, dirt particle attracted towards the oil and fat. So first here what should be there? Fat or oil, and on this fat or oil globules. This is fat or oil globules. Here only dirt particle will be attracted. Okay. Now what you will do? You will start rubbing the soap. Okay. First you will sink this cloth to the water, and afterwards you will start rubbing the cloth. So when you rub the soap on cloth, then what would be there? These soap molecules will be ionized into stearate ion form and sodium ion form. So sodium ion will go out. Sodium ion will go out. They are nothing to do with now with this ion, stearate ion. Now these stearate ion, they will orient themselves. Now I am deleting this one. They will orient themselves around this fat or globules particle like that only. Just see, this is head part, this is tail part. Yesterday also I told you the same thing. Here also this is head, this is tail. Here also this is head and tail. So this is negative part, this is COO part, negative, negative, negative. Here you can write, what is this one? This part is, now here two parts is there. This part is hydrocarbon part. What is this one? Hydrocarbon part. Hydrocarbon part. And you know that hydrocarbon part is hydrophobic. What is this one? Hydrophobic. And what is this part? This is ionic part. Ionic part. And this part is hydrophilic. This part is hydrophilic. Okay, so just see, this is hydrophilic part. Okay, hydrophilic part, write down here. This is same way, all are having. And what about this one? This is tail. What is this one? This is hydrophilic part, or this is head, you can say. What about this one? Hydrophobic part. Hydrophobic part, that is tail. Okay, no problem at all. And now just see, it doesn't mean that only one bit be there, many would be there. Negative, here also you can make negative, here also you can make negative, here also you make negative. Now try to understand. Now micelle is formed, micelle formation. Here write micelle formation. Now all soap ions, stearate ion, orient themselves around this fat or oil particles in a such a way so that its hydrophilic part should be towards the surface of water or should be at the surface, and hydrophobic part should be interior of the cluster. So this micelle formation, or this is cluster. What is this one? Cluster. Okay, no problem at all. And around this one, what should be there? That sodium ion which are ionized, they will be out. Here also Na positive, Na positive. Here also Na positive. Here also Na positive. Here also Na positive. They are out. Now everywhere what is there? Water is there. What is there? Water. Okay, because medium is water only. Now micelle is formed. Now try to understand. If you see carefully, all these head part has got the negative charge. So because of being a similar charge, what is there? These head part, they will repel. In one micelle only, there are so many stearate ion, and all have got negative charge at their head. Because of that, they will repel each other, because similar charge always repel each other. Because of this repulsion, what is there? Now they will go apart from each other. So when they go apart from each other, this fat or oil globules, they will disintegrate. What will be there? Disintegrate. They would disintegrate. When they disintegrate, they will make very, very fine globules of fat and oil. Now what would be there? Now this is disintegrated, and here only dirt is there. This fat and oil globules, they will be disintegrated into very, very fine globules or particles. Now they are disintegrated. Meantime, what you will do? You will add the water further. So these disintegrated fat globules, they will mix. I am writing this side. They will they will mix with water, and form emulsion, they will mix with water and form emulsion. Okay, because water is also liquid and these fat globules are also now liquid only, so they will mix together and form emulsion. Now slowly this entire fat and globules will be disintegrated and they will form emulsion with the water, and with the stream of water they will run away. So now in this way soap only has cleaned. Who has cleaned? Soap only cleaned. That is why I wrote the cleansing action of soap is based on two things. First, micelle formation, that is the cluster, and second one is the emulsion. When emulsion will form? Because of the same charge of head of stearate ion, what is there? They will repel each other. Because of this repulsion, what is there? They will go away. When they will go away, then what is there? Now this fat and globules particle, they will disintegrate into very fine globules, and with the addition of water they will form emulsion and they will go away. Now in this way the cleansing action of soap is over. So once again, what are the micelle? What are the micelle? Micelles are the clusters of ion in which they orient themselves in a such a way so that their hydrophilic part, what is this one? Hydrophilic part should be at the surface of cluster, and hydrophobic part should be interior of the cluster. Over. What are the micelles? Simple thing. Micelles are the clusters of ion, or micelles are the clusters of ion in which they orient themselves in a such a way so that their hydrophilic part should be at the surface of cluster, and hydrophobic part should be interior of the cluster. Hydrophilic at surface, hydrophobic in interior of the cluster. Over. So this is one way. Soap, remember this one. Who is forming the micelle? Micelles are formed by those substances in which substance had got two parts, hydrophobic and hydrophilic. Those kinds of substances are only will form the micelle. In the same way detergent will also form. What are the detergent? Detergents are the ammonium, sodium, potassium salts of higher fatty acid. They are also higher fatty acids only, but minor differences are there. They will have the hydrocarbon part or cyclic hydrocarbon part. So now it is there, will teach you later on, especially it is included in the UPSC. So right now cleansing action of soap is over. Now method of preparation of sols. Sol means colloidal solution only. Sol means solid in liquid. So if I am talking of colloids, it means I am talking of solid in liquid, sol only. Remember this one. So dear cadets, now there are so many aspects we have discussed as far as colloids are concerned. Now let us move to another topic, that is methods of preparation of colloids or methods of preparation of sol or sol, S-O-L. Okay, means if I am writing sol, it means solid in liquid type of colloid we are discussing. So just see, as far as methods are concerned, according to NCERT book, 3 methods they have given, okay, in the syllabus, and we have to discuss those methods only. The first method is chemical method. Second method is Bradig's arc method, or this is also known as electrical disintegration method. Third method is peptidation method. So under chemical method, we'll begin with chemical method only. Now what are the chemical method? Just see, all in 10th class you studied different types of reaction: double decomposition reaction, oxidation reaction, reduction reaction, hydrolysis reaction, displacement reaction, double displacement reaction. So many reaction you studied or not? So they are the types of chemical reaction. Are you getting my point or not? So chemical method means we are talking of preparation of colloids by chemical reactions. Am I correct or not? So just see double decomposition method. First method is, what do you mean by double decomposition method? Double decomposition method is nothing but a exchange of ion reaction which is carried out or carried forward by the exchange of ions. Just see here. Here this is arsenic oxide. What is this one? Arsenic oxide, As2O3. It is reacting with hydrogen sulfide. So just see, oxygen is going with hydrogen and sulfur is coming with arsenic. So you will get the arsenic sulfide plus H2O. Okay, and this arsenic sulfide is only salt, colloids. Am I correct or not? See, have you got my point? Simple thing. What is the meaning of double decomposition reaction? Double decomposition reaction is the reaction in which exchange of ions takes place. Okay, so just see, with the arsenic here oxygen is there and with the hydrogen sulfur is there. Now sulfur will come with the arsenic and oxygen will go with the hydrogen, and now your product is ready. So this is arsenic sulfide. Just see, arsenic sulfide formula. See, this is 3 positive, sulfur is 2 negative, crisscross this one. So As2S3. Am I correct or not? Same way you can arsenic oxide, oxygen is 2 negative, this is 3 positive, crisscross this one. So As2O3, this is arsenic oxides. So double decomposition method is over. Next one is hydrolysis. Hydrolysis means chemical reaction with the water. Am I correct or not? There is a difference between hydration and hydrolysis. Hydration means addition of water molecules, and hydrolysis means when the water, what is the chemical formula of water? H2O, HOH. So when water react with the help of H positive and OH negative, that reaction is known as hydrolysis reaction here, or chemical reaction of water. So here hydration is not there, hydrolysis is there. Hydration means addition of water molecules. So just see, this is FeCl3, it will react with the water. So now OH will come with this one. Now here iron hydroxide plus HCl you will get. Now iron hydroxide is only salt. Next method is oxidation method. What is the meaning of oxidation? Addition of nascent oxygen or addition of electronegative atom. Am I correct or not? Addition of nascent oxygen or addition of electronegative atom. Just see here, this is sulfur dioxide, it is reacting with the H2S. Okay, H2S. So just try to understand here. We can define oxidation in 2 ways: addition of nascent oxygen or addition of electronegative atom or ion, or removal of means reverse of that one. Addition of nascent oxygen or removal of hydrogen, addition of electronegative atom or removal of electropositive atom, both are oxidation. So just try to understand here. See here, what is there? See, sulfur atom SO2 plus H2S. So now product is here sulfur, this sulfur and H2O. Now in both case sulfur is there. So here sulfur is removing the hydrogen. So sulfur is undergoing oxidation. Am I correct or not? Just see, addition of nascent oxygen or removal of electropositive atom, that is hydrogen here. So electropositive atom is removed here or not? Now sulfur salt is formed here. Okay. Next one is reduction. What is the meaning of reduction? Reduction means addition of nascent hydrogen or removal of nascent oxygen, or addition of electropositive atom or removal of electronegative atom or ion. So just see, this is gold chloride, auric chloride, this is formaldehyde, this is water. So now just see, in this reduction very easily you can find out. Just see, oxidation and reduction. Just see, I will write here only. What is the oxidation state of sulfur? +4. But what is the oxidation state of sulfur here? 0. So +4 to 0, there is a decrease in the positive oxidation state. Am I correct or not? So when there is a decrease in the positive oxidation state, then what is there? What is the name of that reaction? Reduction. Now just try to understand here. Here oxygen is -2, here also oxygen is -2. Here hydrogen is +1, sulfur is -2 here, but here sulfur is 0. So -2, 0. There is an increase in the positive oxidation state. So sulfur is undergoing oxidation and sulfur is only undergoing reduction. So if the same substance undergo oxidation and reduction, what is the name of that reaction? Disproportionation reaction. So of course this is oxidation reaction, but it is one type of disproportionation reaction. I hope that you are getting, otherwise just see. SO2 plus H2S. So sulfur plus 2H2O. Just see. What is the oxidation state of sulfur here? +4. What is the oxidation state of sulfur here? 0. So +4 to 0. There is a decrease in the positive oxidation state. So what is the meaning of this one? If there is a decrease in the positive oxidation state, that is reduction. Now what about this one? Oxygen is -2 here, oxygen is again here -2. So there is no change in the oxidation state, means oxygen neither undergoing oxidation nor undergoing reduction. What about hydrogen? Hydrogen is +1, hydrogen is +1. So here also there is no change in the oxidation number, oxidation state. It means hydrogen is also not undergoing, neither undergoing oxidation nor undergoing reduction. What about this sulfur? This sulfur is here -2, but this sulfur is here 0. So there is a increase in the oxidation state. So here oxidation. So there is a increase in the oxidation. So means there is a increase in the positive oxidation number. So this is oxidation. Now try to understand. Sulfur is undergoing reduction and sulfur is only undergoing oxidation. So such kind of reaction is also known as disproportionation reaction. It means if the same substance undergo oxidation and reduction, that reaction is known as disproportionation reaction. Last year you have studied. So here our purpose is not to teach you oxidation reduction. The purpose is to teach you the sol, how the sol is formed. So sol is formed by oxidation method also, reduction also. So in this way the chemical method is over. Just you remember these reactions. Sometime in 1 marks and 2 marks question they may ask, write 1 or 2 chemical methods for the formation of sol or colloids. So you should remember this one. These reactions are very easy. Either you can remember oxidation or hydrolysis. Either one you can remember. So the first method is over. Now second method is Brady's arc method. Now first method I am deleting here so that the space should be there on the blackboard. Just see. In the Brady's arc method, what we are doing? We are taking the electrodes of the metals whose colloidal solution is to be prepared. Just see. Brady's arc method. I am deleting this one also. Now second method here. Note down here heading, upper side just write. See. Brady's arc method. Brady's arc method. This is also known as electrical disintegration. Electrical disintegration. Okay. Brady's arc method or electrical disintegration method. You do one thing, simple. Just see. Take one apparatus, let us say beaker. Now inside of this one take another beaker, okay, and now select the 2 metals electrode whose colloidal solution is to be prepared. Suppose I want to prepare the gold sol or colloids of gold. So now here take 2 electrodes of gold. This is electrodes of gold. You can take platinum also. Now gold is very costly, so just take, this is PT electrode. What is this one? PT electrode. Here also what is there? PT electrode. Okay, platinum electrode. Okay, this one and this one. Now one dispersion medium should be there. Now here I took water dispersion medium. Okay, dispersion medium, no problem at all. Now try to understand, this smallest one apparatus should be kept in the ice cold, means ice, under ice cubes. So these are ice cubes, because a lot of heat will be generated, and if you will not take ice cubes here, so that metal may evaporate. Okay, so these are ice cubes for the cooling purpose, so just try to understand here. Now supply the electricity through the electrodes. Okay, then what would be there? Here electric arc will be developed. What is developed? Electric arc. And because of this electric arc, these metals will be disintegrated. Okay, will be disintegrated. These metal electrode will be disintegrated. And now the pieces of same metal or powder of same metal will be dissolved in the water. A lot of heat is generated. Because of high heat only, this metal electrode will disintegrate or decompose. And now this metal will dissolve in the water. So when this metal will dissolve in the water, now what would be there? Now here you kept ice cubes. So then what is there? Of course temperature is very high, but because of these ice cubes, temperature will come down. And now this metal will dissolve in the water. And slowly their concentration will increase, and the colloidal solution of platinum metal is ready. Now it doesn't mean that platinum only you have to take. If you want to prepare the colloidal solution of gold, you should take here gold electrodes. So in this way it is very easy. Just see, make the electrode, develop the electric arc. When electric arc is developed, intense amount of heat will be generated here. Because of that intense heat, this metal will decompose and their parts will dissolve in the dispersion medium, water. Okay, and now because this arrangement is kept under the ice cubes, so it will cool down. So further what would be there? Further evaporation is there. Whose evaporation? Metal evaporation. Okay, and afterwards under these ice cubes, condensation will be there. So first metal will evaporate, but ice cubes are there, so it will condense, and now they will dissolve here only in the water, and colloidal solution is ready. So this method is also over. The next method is peptization, and that is most important. In the short note, sometimes they ask, what do you mean by peptization? So first one, so, cadets, please write this point also. In this portion, metal get dissolved due to continuous electric spark and form colloids. Yes, that much only. Over. So Brady's arc method is over. So dear cadets, now peptization. This is the third method of preparation of colloids. So number one thing is, it is the process of preparation of lyophobic colloids. Just remember, what is this one? It is the process of preparation of lyophobic colloids. Actually, what is the peptization? Remember, peptization is nothing but a method of conversion of freshly prepared precipitate into colloidal solution or colloidal particle. So what is peptization? Peptization is the process of conversion of freshly prepared precipitate into colloidal form by the addition of small amount of electrolyte. And the electrolyte which is added there, that is known as peptizing agent. What is that one? Peptizing agent. Always remember, it should be added in small quantity only. Otherwise, another process that is known as coagulation will start and you will not get the colloidal particles, colloidal solution. So now their small amount should be added. So here who is playing important role? Actually that electrolyte which is added, that is playing important role. Okay. Now question arises here, how electrolyte is converting precipitate into colloidal form? How it is converting one precipitate into colloidal solution? So just try to understand, just see. First try to understand, precipitate means insoluble substance which is formed during the course of formation of solution. Precipitate is insoluble substance which is formed during the course of solution formation. Okay. Now precipitate is insoluble, so it may be at the surface of solution or it may be settled at the bottom. Both cases may be there, but it must be insoluble only. So now in colloidal solution, that is precipitate is there. Precipitate means insoluble substance. Now in that insoluble substance you are adding small amount of electrolyte. Electrolyte you know. So when you add the electrolyte, what freshly prepared PPT will do? According to the nature of PPT, precipitate, suppose it is the precipitate of iron hydroxide, FeOH whole thrice. So now one electrolyte you select in a such a way which must contain the common ion with the colloidal PPT or precipitate. Means if precipitate is iron hydroxide, so the electrolyte which you are selecting, that also must contain either of ion. Now your PPT is FeOH whole thrice. So what are the ions here? Fe3 positive and OH negative. So the electrolyte which you are selecting, it must contain at least one common ion. Either it contains iron ion or it must contain OH negative ion. So here just see, we'll explain this one right now. Just you keep on noting down these points. So peptizing agent are electrolytes common, just try to understand here. Peptizing agent must be selected in a such a way so that it must contain common ion with colloids. Peptizing agent are electrolyte one common ion adsorbed at the surface of colloidal particle and made them charged. Since all colloidal particles in the dispersion medium now are having same charge, hence they will repel one another and they will not come close to each other, and now those particle size range falls in the range of colloidal particles, that is 1 nanometer to 1000 nanometer. So this is the important point regarding the peptization. All those things should be written. Now let us see the explanation part. Just wait. So dear cadets, now means explanation of peptization. So small addition of electrolyte stabilize the colloids. How? Just see. This is FeCl3. Okay, you subject it for hydrolysis, and you know that by the hydrolysis process we can make the colloidal solution or colloids. So subject it. This is iron chloride. Subject it for hydrolysis. What you will get? FeOH whole thrice plus 3HCl. This is insoluble substance. What is this one? Iron hydroxide. What is the name of this one? Iron third hydroxide. What is this one? This is insoluble substance. What is this one? Insoluble. So this is insoluble, hence we can say this is precipitate. The short form of precipitate is PPT, insoluble substance. The insoluble substance is known as precipitate. PPT means Precipitae. Yes, precipitate. Okay. So you have got this precipitate, iron third oxide, hydroxide. This is only sol. This is not, right now it is not sol. This is precipitate. Okay. Now you have got iron third hydroxide, FeOH whole thrice. Now what is the meaning of peptidization? Conversion of freshly prepared precipitate into colloidal form by the addition of small amount of electrolyte. Now select one electrolyte. Select one electrolyte which must contain common ion. So just see here how many ions are there? 2 ions are there. Fe3 positive and OH single negative. These are the ions. So I am selecting one electrolyte which must contain the common ion. Let us see, I selected here iron chloride, FeCl3. Now you may raise question, sir, you have here also you have taken FeCl3, here also you have taken FeCl3. Remember, there are limited amount of salt of iron which are decomposed into ions freely, easily, isn't it? So here this FeCl3 is nothing to do with this FeCl3. This I have taken for the formation of precipitate. This one I am taking as a electrolyte. So that is difference or not? This is electrolyte and this is for the formation of this freshly prepared iron third oxide we have taken. So here it is reactant and what is here? It is electrolyte. So try to understand, when it dissociate this electrolyte, what it will do? It will furnish the Fe3 positive ion. What it will do? Now separately you can take, we can write, I am just dissolving this one. This can be written like that also. See, Fe3 positive plus Cl negative. Now try to understand. You can write in this way, you can write in this way. There is no problem. Now here 3 Cl negative ion. Now just see. When FeCl3 ionized into Fe3 positive and 3 Cl negative, which is the common ion here? Which colloids is also having? The common ion is iron. So the rule says that only common ion will be adsorbed at the surface of precipitate. This is PPT, precipitate. So at its surface, write down here FeOH whole thrice. Now suppose this is one molecules of FeOH whole thrice. So this Fe3 positive ion, Fe3 positive ion, Fe3 positive ion, this is Fe3 positive ion, Fe3 positive ion, Fe3 positive will be adsorbed at the surface of this one, Fe3 positive. Around this one iron hydroxide, everywhere Fe3 positive ion will be adsorbed at its surface. Then now what would be there? Now try to understand. We can write in this way also. Just see, FeOR, FeOH, OH whole thrice. This molecules here positive, 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 positive. So this is the story of one molecules of precipitate. Now all molecules will have the positive charge at their surface. So means we have taken the freshly prepared iron hydroxide. Now it has adsorbed positive charge. All the molecules of precipitate adsorb the positive charge. So they will repel each other or not? They will not now come close to each other. If they would not have been positively charged, they could have associated with each other. But now what is there? Because of being a similar charge particle, they will go away from each other. And once they will go away from each other, so their particle size range will fall within the range of colloidal particle. And what is the range of colloidal particle size? 1 nanometer to 1000 nanometer. That is why now this electrolyte, added electrolyte, which is having common ion, stabilizing the colloidal particle. If this charge would not have been developed, all will have associated, and once they associated, they may form the suspension particle. In case, what is the difference between true solution, colloidal solution, and suspension? Only the particle size, that only matters. Same substance can form the true solution, colloidal solution, and suspension. Just see, NaCl form the true solution, but if the concentration of NaCl is very high, it forms the associated colloids. Am I correct or not? So just see here, same substance can form true solution, colloidal solution, and suspension. What is the matter here? Particle size. So because of adsorption of common ion at the surface of iron hydroxide, they will not associate with each other. Otherwise, they would have formed the suspension particle. Now, because of this colloidal particle, this electrolytic ion, you can say, they are stabilized. So what is the function of peptizing agent here? The function of peptizing agent is, what is the function of peptizing agent? Function of peptizing agent. Function of peptizing agent is to stabilize the colloidal particle. How? I have explained or not how they are stabilizing? Because of their similar charge. Now, who has developed this similar charge? Because of the adsorption of common ion from the electrolytes. All are now equally charged particles, same charge particle, and they will repel because similar charges repel each other. And now this is blessing in disguise. If they are apart from each other, then they are stable. If charge is not, means opposite charges are there, they would have associated. So that is why we should select the electrolyte which is having common ion. Always remember. And that common ion only will adsorb at the surface of freshly prepared precipitate. So in this way, this is completely completed. So now, one more thing is there. Just remember this one. The small amount only, already I told you that only small amount should be added. Otherwise, another process would happen, that is coagulation. Coagulation will teach you in upcoming videos. That is there in the syllabus. But right now, this is the matter. Thank you very much. I hope that you understood this one. Now tomorrow I will teach you the purification of colloids.